Alright guys, what I want you to do now is I want you to go ahead and try this on your own with the cards that you received. On the left side, I want you to remember the characteristics of proportional, and I want you to put all of the ones that you feel are proportional relationships on the left. On the right, I want you to put all of the ones that you feel are non-proportional based on the Frere model foldable that we did. So if you want to pause the video and we will check our answers in just a moment. Let's go ahead and look at our first graph. The easiest way, if you remember, the easiest way to determine if a graph is proportional or non-proportional is to look and see if it crosses at the origin 0, 0. Let's go ahead and hold our pencil point at 0, 0, the origin. Does the line intersect at that origin 0, 0? No, it doesn't. Therefore, this is a non-proportional relationship. Let's go ahead and grab another card. This is an example of a table. Remember, in a table, we need to look at the constant rate of change. We want to determine how, with multiplication, we can get from 1 to 7. So to get from 1 to 7, what do? We multiply by 7. Very good. Let's go ahead and see if that rate applies to the next bouquet. If we buy 2 bouquets, 2 times 7, we get the value 14. So we should have 14 flowers. Is that what the table tells us? No, it doesn't. The table tells us that we should have 10 flowers, when if we have a constant rate of change, we should have 14. Since we do not have a constant rate of change that works, this table is non-proportional. Let's take a look at another one. This time, let's take a look at an equation. The easiest way to determine if an equation is proportional or non-proportional is to see if we have any other operation other than multiplication. Let's look in this equation for multiplication. I don't see a multiplication symbol. I do see a variable here, but I know that 2 things side by side means to multiply. So since my equation only has multiplication, I know that this equation is a proportional relationship. Let's go ahead and let's try one of the words. The words are always the trickiest for me, but once you get the hang of it, you can do this. It states that a corporate team building event costs $31 plus an additional $16 per attendee. Is the total cost directly proportional to the number of attendees? So it costs $31 plus $16 per attendee. So if I have 1 person, it would be 16 plus the 31, right? If I have 2 attendees, it would be 2 times 16 plus the $31. So I'm going to go ahead and try to write an equation to help me. Or you already know, since we have to add that $31 to it, are we just multiplying here? No, we're not. Therefore, it is a non-proportional relationship. Let's go ahead and take a look at another graph. Remember, the easiest way to determine a graph is to look at the origin. For it to be proportional, it must cross the origin 0, 0. Let's look. Put our pencil on the origin. Does the line intersect through the origin 0, 0? Yes. Therefore, this graph has a proportional relationship. So we're going to put it on the proportional side. Let's take a look at the next one. Let's look at this equation. When we're looking at the equation, we want it to show just multiplication. Does this equation show just multiplication? Well, no, right here it shows subtracting 6. So is this equation proportional or non-proportional? That's right, it is non-proportional because it has something other than multiplication. So we put that on our non-proportional side. Let's go ahead and take a look at this table. Notice that when we look at the table, we want to see the order it goes on the X. It says 1, 10, 14, 18. It does not go in counting order, so we have to be very careful to determine if it has a constant rate. How do we get from 1 to 200 with multiplication? Yeah, we take that and we multiply 1 times 200. So, if we do 1 times 200, let's go ahead and see if we can do the next one to get our milligrams. 10 times 200. Work it out to the side if you need to. Does it match what our table tells us? Very good. You're absolutely correct. It does. Let's try to see if our next one works because we need to make sure. 14 times 200. And let's go ahead and see if it works. Work it out to the side. Yes, it does work. Very good. So we can tell that this has a constant rate of change because each are multiplying times 200. So since it has a constant rate of change, we know that this table represents a proportional relationship. So it goes right here on the left side underneath proportional. One more, guys. We're almost done. And it's a word problem, so we have to read carefully. Kirsten buys 9 postcards during each day of vacation. It is the total number of postcards bought proportional to the number of days spent on vacation. So, guys, if she spent 1 day on vacation, how many postcards? 9, okay. If she spent 2 days at vacation, how many postcards? 18. If she spent 3 days at vacation, how many postcards? 9. So each day she multiplies 9 times 9 times 9. So it has a constant rate of change. Therefore, it is proportional. I hope you got them all right. If not, I hope you understood as we went over them. So go ahead and move them to the right side if you got them wrong and make sure that you understand. If you have any questions, just raise your hand.